Graphing quadratic functions. The shape of the graph is called a parabola. P-A-R-A-B-O-L-A. Parabola. Say that. First learned it to be able to learn to spell it. I had to say it parabola, which sounds like an African virus that you probably don't want to catch. Yeah, that's what it kind of sounds like. But parabola is the correct way of saying that. So the shape is called a parabola. It looks somewhat like a U kind of shape. Either opens up like that or opens downward. And there are parts of the function that determine which one of those pictures it's going to be out of that. So let's just get into all those particulars, all these different things that we're going to find for graphing a parabola. And the way kind of assessment goes on this is they're going to ask, I'm going to ask for like individual pieces, not everything for every single problem. We're going to practice doing everything for every single problem. But the way you want to think about this is be able to find an individual piece. Like if I say find the vertex, be able to do just that instead of having to do everything in the whole problem just to find that one piece. Okay, so as you're going through this, we're going to look at them as individual pieces, but they all interrelate together. So a parabola or quadratic function can be in several different forms. The first form looks like that. F of x, that's the same thing as y, remember, is ax squared plus bx plus c. Okay, that looks a lot like the quadratics we were solving by factoring, where we had to do a times c and do the x thing to do that, or the quadratic formula worked with that as well. We just had to set it equal to 0. That's going to come up today too. But quadratics, this is what's called standard form. Okay, this is standard form. Okay. Standard form, there's a if the value of a is greater than 0, what kind of number is it? If a number is bigger than 0, what kind of number is it? Positive, right? If the value of a, the number in front of x squared, is positive, then it opens up. So it's going to be that picture. If a is less than 0, what kind of number is it? Negative. It opens down. It's going to be that kind of picture. Okay. All of that, the direction this thing opens, is decided by the number that's in front of x squared. If it's in standard form, a decides that. The beautiful thing is, when we go to the other forms that we're going to talk about today, this a does all the same things, no matter which form we have. Okay? So, no matter what form we're in, they're all going to have an a in there. And if a is positive, it's going to open up. If a is negative, it's going to open down. Then there is an important point down here at the bottom of the ones that open up and at the top of the ones that open down. Does anybody remember from Algebra 1 what that point at the lowest point or the highest point is called? Minimum or maximum? That's true, but it had a different point. Vertex, that's right. It was called the vertex. If a is positive and it opens up, that vertex is at a minimum. So that's combining everything you guys just told me. Minimum value on the vertex. If a is negative, it opens down. The vertex is at a maximum. Okay. Minimums and maximums. Okay. Minimum, lowest point, maximum, highest point. Okay. So with that, That gets us into all of the different parts we're going to find. So let's start looking at the parts we're going to find. The first thing that we're going to find is the axis of symmetry. The axis of symmetry. It is this imaginary line. It's so nice outside. All right, so the axis of symmetry is this imaginary line that goes down the center of those parabolas. So with these, it's this imaginary line that if I folded that graph right across the axis of symmetry, it matches up on each side. That's what symmetry is matching up on each side. So the axis of symmetry, if we're in standard form, the equation of the axis of symmetry is x equals negative b over 2a. So you go to the form, negative b, or whatever the opposite of what's in front of plane x is, divided by 2 times a. That's kind of similar to part of the quadratic formula, because it is part of the quadratic formula. Okay, so we would, when we get a problem, we'll do an example here in a minute. We're going to use this formula to get the axis of symmetry. The wonderful thing about that is the next thing we're going to find is that vertex. And the vertex is an ordered pair. The x value of the vertex matches the value of the axis of symmetry. So it's always going to be negative b over 2a. If we're in standard form, that's what the x value of the vertex is going to be. The y value of the vertex, if we have an x value, we can find a y value by plugging in that number into the problem. That's what we're going to do to find the y value. And the notation I'm using is function notation. This just says put negative b over 2a into the problem and work it out. That's all that means. Okay. Function value for negative b over 2a. Once we found the vertex, we can decide if that's a max or min based on a. Remember, and we'll state that as we're doing this, whether it's a maximum or minimum. And then the next things that we're going to find are some intercepts. Okay, so we'll start with the x-intercepts because those are the hardest. To find the x-intercepts, we're going to set the function equal to 0. Ax squared plus bx plus c equals 0. Well, what do you know? That's exactly what we just finished doing, right? The last test we took was finding the zeros. We called it, or solutions to a quadratic equation. We're finding the zeros, the x-intercepts, the solutions. Another name for them is roots. X-intercepts has a lot of names, so we'll put those down. Roots, zeros, solutions. All of those mean the same thing. X-intercepts, roots, zeros, solutions. All mean the same thing. Set the thing equal to 0 and solve it. That's what it means. Okay. What are our options for solving that? We can do factoring or quadratic formula. Those are my two methods that I use to solve that. Okay, to find the x-intercepts. Okay, so that's what we're going to do with that when we get an example here. The next thing we're going to find is much easier. It's the y-intercept. To find a y-intercept for any kind of problem, we plug a 0 in the place of x. And it doesn't matter what A and B are, because I'm going to end up multiplying them by 0. What's A times 0? What's B times 0? 0 plus 0 plus C is C. The y-intercept is always C. Whatever C is the y-intercept. X-intercept is going to be setting a problem equal to 0 and solving and getting ordered pairs out of that. And then the y-intercept, plug a 0 in for x, work it out. That's going to get you that. If we're in standard form, it's always going to be C. So there's a little bit of a shortcut if it's in standard form. If it's in one of the other forms, there's no shortcut. You still got to plug a 0 in and work it out. Okay. So y-intercept, x-intercept. The next thing that we're going to do is make a table. So the last thing before we draw the graph is the table. And when you're making a table, we'll pick x values and y values. When you make that table, I want you to put your vertex in the middle. Okay. Vertex in the middle. The reason we want to do that is so that we get a picture. Remember, our graph is supposed to be symmetric, right? So we want to get some x values on the left side and x values on the right side. We want to get some x values on both sides. So if we put the vertex in the middle, then we can pick x values that are less than the x value of the vertex that go above it and greater than that on below it. Just a couple on each side is all it takes. Okay. So we're going to set the vertex in the middle, and then the last thing we're going to do is draw the graph. Okay. So we're going to find all of these things for a quadratic in standard form. So let's attempt to do so. Start with this one. Example 1, f of x is equal to x squared plus 6x plus 9. So the first thing I'm going to find is the axis of symmetry. You can abbreviate that if you want to. I'm just going to write it out for notes purposes. That is in standard form. Got ax squared plus bx plus c. So that's in the right form to use the things that we just talked about. So to find the axis of symmetry, we're going to use that formula, negative b over 2 times a. What's b in this problem? 6. So negative b would be negative 6 divided by 2 times a. What's a? 1. So we have negative 2 divided by 2, which is negative 1. The axis of symmetry is x equals negative 1. That is the equation of the axis of symmetry. I don't know why I put that there. You said negative 6, didn't you? Negative 3. My bad, guys. Where my brain was, I don't know. Because you guys said negative 6, and I said, yes, that's right. And wrote the wrong number there. All right, so negative 6 divided by 2 times 1, negative 6 divided by 2 is negative 3. So our axis of symmetry is that x equals negative 3. The good news is we've done half of our vertex already. We have the x value of the vertex. So the second thing I'm going to find is the vertex. I'm just going to go over here to the right. It's going to take up as much space. I already know that the vertex is at negative 3, and then all I got to do is find the y value that goes with it. Okay, and this is where I'm going to start employing the use of my calculator a little bit, because I can make this work a little easier for me by using the graphing calculator. Break out your calculator and get it up and running here. Everybody get that out. Now, it's a graphing calculator. We're graphing quadratics, right? Makes sense that we would use this as a tool. So I'm going to hit y equals. And I'm going to clear out any other equations that I might have. I don't have any others that it look like. I don't. So on y1, I'm going to type in my equation, x squared plus 6x plus 9. X squared plus 6x plus 9. I'm going to hit graph. We see that shape, right? Now, Which way is that opening? Up. So it has a what? Minimum value, right? At that spot. We know the x value for that spot because we did the negative b over 2a. So I'm going to trace -3. So I'm going to hit the trace button right there beside graph, so right up here. And then I'm going to type in the -3 that we found. -3 and hit enter. And down at the bottom, it's going to show me the ordered pair. It's -3, 0. Anybody's not graphing like it should. Yeah. It zooms 6. And then you got a step on system. See how that's dropping in up there? Again. No, it's not. Now all you got on there is that. Now hit trace and then -3. Now you got one there. Hit zoom 6. Another 6 in there. Now you're in the now trace and how to take
Oh, okay, Karen. I did what you did.
7, 6. 7, 6. Yeah. Hit the trace. Negative. I know what you that's we'll see how that starts meaning. Now now it's working right. Okay. Hit trace. Then you gotta start. See how that starts meaning? Press the up arrow. Leaning down. Now I'm going to trace. -3. You got step one. Press the arrow. Hit enter to turn it off. And then trace. -3. Yep. Same thing. Get lines. See how that plot one is turned on, there's the arrow. Hit enter. Now we hit graph. Now hit zoom. 6. Now you got the right picture. Hit trace. -3. Did you type in hit trace? -3. Yeah, type it in there. That's what it's supposed to look like. Yeah, that's right. All right, you got to start. Press enter, turn it off, and that's it, right. All right, hit enter. Zoom. 6. That's what we said here. Window to the right size. Now it's graphic. Okay. Now we trace. Top -3. So you gotta do that each time. No, you won't have to do that zoom 6 and all that stuff. You'll be able to graph it and hit trace and then whatever. Did everybody get graph now? You got that order pair at the bottom. All right. We now have the vertex value, -3, 0. We know it's a minimum because this graph opens up and it's at the bottom, right? That makes sense. Okay. Now, the third thing we're finding are the x-intercepts. Okay. So we're going to take that equation and do what with it? set it equal to 0. Okay, when we set that problem equal to 0, that opens up the possibilities of using either factoring or quadratic formula to solve that. Pick your poison. I don't care which way you do it. I'm going to use factoring because I already know the numbers that multiply to be 9 and had to be 6. Okay, so factoring is a lot of times, for me, it's quicker, but sometimes it doesn't work. So I like to use it when it does work because I'm fast at it. If you're not great at factoring, but you were pretty good at quadratic formula, maybe that's the way you want to find your x-intercepts, which I'm fine with that. Either way, doesn't matter. Okay, and then we get x plus 3 equals 0, x plus 3 equals 0. We get a repeated solution there that x equals -3. That's if you did quadratic formula, you would know that the discriminant of that would be 0 if you did quadratic formula. You should have found that what was under the square root was a 0. Okay, so we have the x-intercepts. Get now the y-intercept. Again, we're plugging in 0 for x, but we know the shortcut to that is that because it's in standard form, what should our y-intercept be? Nope. It should be c, which would be 9. If we look at our graph on our calculator, where's it crossing the y-axis at? 1, 2, 3, 4, 5, 6, 7, 8. Right there at 9. We can see that happening. Okay, so when you've got the calculator in hand, that all these things should match up with what we're doing. We found the vertex at -3. It's also crossing the x-axis there, so that's the same number we found when we did the factoring or quadratic formula to solve it. Gets you the same value. So all these things should be matching up when we find that. And then the last thing that we're going to do is a table. And this is where the calculator really helps out. So the last thing we're doing manually is the table. So on the table, x on the left, y on the right, we're going to put the vertex in the center of that table. So I'm just going to put the vertex was at -3, 0. I'm going to pick two x values to the left of -3. So that'd be -4 and -5. And then 2 to the right would be -2 and -1. All I did was subtract 1 to go to the left, add 1 to go to the right. Okay. Now here's where the graphing calculator can really be nice, because we can make it create a table for us. So everybody on your graphing calculator, we will only have to do this setup part one time. You won't have to do this anymore after this. The setup that you have to do is hit second and then the window button, which is right beside the y equals. It does not matter what yours has at table start or at delta table. Doesn't matter what's there. Yours could have any numbers there. Mine has 0 and 1. It doesn't matter. What you want is the independent set to ask. So arrow down there. If yours is set up like that, arrow down, move over to ask, hit enter. Make sure the dependent is on automatic though. Okay. Independent is X, dependent is Y. That's what that means. Okay. Anybody having trouble finding that spot? Okay. Once you've done that, we're here, we've typed in our equation. We need to make a table. So we're going to hit second graph to get to this screen. You may have a bunch of values here that are already typed in. You may have none of them. Yours may be blank, and that's okay. I've got some that I've typed in the last, 8 months of school. Okay, so I've used this. Your memory may have been cleared since then. So what I want to do is type in the table those x values that I've written down the x side. So I'm going to type in -5, -4, -3, -2, -1, and just hit enter every time. -5, -4, -3, -2, -1. and I get the y values that go with them. Right there. Should have 4, 1, 0, 1, 4. Anybody not getting those? Everybody good? All right. So we're going to write those in our table. 4, 1, 0 is already there. So that's a good checking spot to make sure you got the right value for your vertex. If you use the calculator, it should be right anyway. Anybody else having trouble with your table? All right. Now, here's the beautiful thing. We've done all of the work that it takes to draw the graph of a quadratic. We know what it should look like when we get done because we have this picture on our graphing calculator. So if my picture doesn't look like the picture on my screen, then I know I did something wrong. Right? That makes sense? So I'm going to draw that graph precisely on my graphing paper there. So over on your graph paper, draw yourself a coordinate plane. Doesn't have to be real big because our biggest y value is positive 4. Our biggest x value or furthest away from the origin is -5. So it doesn't have to be real big. And what I'm going to do is just plot those points. -5, 1, 2, 3, 4, 5. Positive 4, 1, 2, 3, 4. -4, 1. -3, 0. -2, 1. -1, 4. And I draw a nice looking parabola through those dots. And I didn't do a very good job there. I'll do better. That's pretty stinking good. That axis of symmetry that we found, that x equals -3, that's this imaginary line that's going down through there. I like to draw it in my graph just so it helps me see if my graph is symmetric and works real good there. But that axis of symmetry should always go right down through the middle of the vertex. If it doesn't, something's been miscalculated somewhere. Okay. Excuse me. Okay. Does that look like the picture that's on my calculator? Other than the red dotted line. Doesn't have that drawn. Yeah, it does. It looks exactly like it. So we've done all the work for a standard form quadratic to draw the graph. Okay. Now, standard form, ax squared plus bx plus c. It makes probably the most work of all of the forms. It has the most work to it. The other forms, one of the other forms that we're going to talk about is one that's called intercept form. And when I was in high school, Mr. Campbell, I don't know if y'all know Miss Patricia Campbell, goes to church over at Sharon, teaches at SCA. She was my math teacher all through high school. She called it factored form. It's the same thing. Okay, factored form, intercept form are the same thing. And with factored form and intercept form, it's called intercept form because it makes it easy to find the intercepts. The x-intercepts are the hard ones to find anyway, right? So if it's in this form, it's going to make one of our calculations a lot easier. The way intercept form works, you have that a value, and then you have two factors. X minus m and x minus n. Those are going to be numbers in there, okay? That looks like we factored that problem, right? That's what it looks like when you factor it. So factored form, here's what I would do. Let's do an example. Let's call it f of x equals -1 parentheses x plus 5, x minus 3. So we know that we're going to find the axis of symmetry, and I'm going to abbreviate here. We're going to find the vertex. we're going to find the x-intercepts. We're going to find the y-intercepts. And then we'll scroll down here and we'll do the table and then the graph. Okay, because we're in intercept form, I'm going to skip the axis of symmetry in the vertex and go straight to the x-intercepts because that's the form I'm in. It's the easiest thing to get, and I can use this to help me get there. How do I find the x-intercepts? Set the problem equal to what? 0. I'm going to set -1, x plus 5, x minus 3 equal to 0. Okay. What do I do next? It's already factored, right? So what do I do with each factor? Come on, guys. You'll know this. Once you factor it, you set each factor equal to what? 0. -1 doesn't have an x. So what happens to it? It just goes away. X plus 5 equals 0. X minus 5 or x minus 3 equals 0. Solve that. -5, 3. The x-intercepts are at -5, 0, and 3, 0. Two different x values there. We could have multiplied it back out and did quadratic formula, but that's a lot of extra work. If it's in intercept form, shoot straight there. Go. Do the work. It's easy. It's too easy. Some of y'all were really good at factoring. Some of you weren't as great at factoring. But if it's already in factored form, you knew what to do. Everybody knew that. Okay? So set each factor equal to 0. Solve it. That's your x-intercepts. I'm going to still use this same form to find my y-intercept. Because how do I find my y-intercept? Plug in what? 0 for x. So that's going to be -1 times 5 times -3. What's my y-intercept? What's -1 times 5? It'd be -5 times -3 is positive 15. 0, 15. These. Now I found my intercepts. Once I found those, then I'm going to go back and get my axis of symmetry in my vertex because I've used up all of the goodness of the intercept form by finding the intercepts first. Quick and easy math for the fact it's already factored for us, so I just do that. Y-intercepts, just plug a 0 in, no matter what kind of form it's in, and work it out. Okay. Now, axis of symmetry is going to be, I think the easiest thing to do is just multiply out the original problem and get it into standard form, then use -b over 2a. In my opinion, that's the easiest thing to do. There are other ways, but I think that's the easiest way. So that's the way that I want to show you. So I'm going to multiply this original problem out. So I'm going to multiply x times x, get x squared. X times -3 is -3x, plus 5x, minus 15. And then I'm going to distribute the -1. So -x squared, -3x and positive 5x is 2x. Make that -2x plus 15. Now I have it in standard form. Look at C plus 15. What's our y-intercept? Positive 15. Those should match up. That's a checking spot for you. Make sure you multiplied it out correctly. Now that I've got it in standard form, I can use the shortcut or the formula for axis of symmetry. Remember, which was x equals -b over 2a. So -b would be 2 over 2 times -1. That'd be 2 over -2, which is -1. The axis of symmetry would be x equals -1. The other method, and I'll tell you this, some of you might catch on to this and want to use this. Others of you will feel more comfortable doing it this way. Where's -1 at in relation to -5 and 3 on the number line? So like if you got a number line, you got -5 over here. Yeah. Right here between -5 and +3, those are 8 apart. Halfway would be 4, right? 1, 2, 3, 4. Boom. That's halfway. Your vertex is always halfway between your x-intercepts, which is correct. Always. So the shortcut could be midpoint of the x values. Midpoint would be add the x's divided by 2. The y values don't help you because it's not part of the axis of symmetry. So you could do it either way. I think, the multiplying it out is the most simple way and probably the most foolproof way. Sometimes if we miscalculate the x-intercepts, then we're automatically going to miscalculate the axis of symmetry, which means we're automatically going to miscalculate the vertex. And if we miscalculate the vertex, guess what else is wrong? Our parabola is wrong because our table is going to be wrong too. So all of those things, if you make a mistake on one of the first parts, dominoes just scatter of everything else gets wrong too. So you've got to be careful about that. All right, so to find the vertex, we plug that in to x in the problem. So what I'm going to do is I'm going to go to my calculator. I'm going to use it to help me. I'm going to type in the original problem, -1 parentheses x plus 5 close parentheses x minus 3. I'm going to hit graph. Pretty sure that's a parabola shape. It's pointing down because the vertex is at what kind of value is the vertex, max or min? It's going to be a max. It's going to have an x value of -1. We need to find the y value. If I hit trace and then -1, it should give me back +16. If I did everything right. +16. And that's a maximum value because it's the highest point on the graph. So what I want to do now is make my table, since I now have the vertex. I'm going to put it in the middle, -1, 16. I'm going to go to the left. So that'd be -2 and -3. To the right would be 0 and 1. I'm going to use my calculator to help me build that table. I'm going to hit second graph, and I'm going to type in those values. -3, -2, -1, 0, +1. 12, 15, 16, 15, 12. So when I draw this one, I've got to make it kind of tall when I draw my coordinate plane for this one, because it's got to go up to 16. I'm going to plot my points. -3, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. -2, 15. 13, 14, 15. -1, 16. 0, 15. And 1, 12. Where do I know it's crossing the x-axis at? The x-axis. At -5 and +3. Those are my x-intercepts, right? So that just helps me draw the parabola a little bit better. I don't know why I changed colors there. My axis of symmetry right down the middle just helps me see that I can fold it across and make it match up. Those are the things I'm going to be looking for when I ask you to graph one. Is your y-intercept in the right spot? Are your x-intercepts in the right spot? Are the other points in the right spot? Okay. Intercept form makes the x-intercepts easy. Everything else, about the same amount of work. Okay. The last form that we're going to deal with is called vertex form. And you may have seen this one before. You may or have not seen it before. In my college algebra class, they call it shifted form. It's the same thing. So if you go on Khan Academy and it says something about shifted form, because you never know who their videos, who's making them. Sometimes they're from across the pond over there, and they'll use the words shifted form. Vertex form, shifted form are the same thing. Vertex form, guess what it makes easy? The vertex. Makes the vertex really easy. Okay. There's the A that we had earlier. And it looks like that. The H and the K are the vertex. Okay. The H that's inside of the parentheses, that's the X value of the vertex. The K, that's on the outside, that's the Y value of the vertex. Vertex form gives you the vertex for free. You don't have to do any work to get it there. You just got to know that form. Okay. Notice how it's X minus H on the inside of the parentheses and then a plus K on the outside. What that implies is you change the sign when you bring it out, but you keep the sign of the stuff on the outside. Okay. Let's look at an example. F of x is equal to 2 parentheses x minus 3 squared plus 5. Okay. Now, again, we're going to find all of the same things. We're going to find the axis of symmetry. The vertex, which we get for free because we're in vertex form. The x-intercepts. The y-intercept table. And I might need some more room to do the x-intercepts on this one because it's not as short as the intercept form was. And then we'll graph it. All right, so here's the beautiful thing. This is H. This is K. So the vertex is right there in the problem. The vertex is going to be positive 3, positive 5. It's a minus sign on the inside here, so we make it a positive when we pull it out. The K value or the Y value of the vertex always stays the same. It's inside there, you swap the sign of it, just like you would when you're finding the intercepts. You know, when it was an intercept form to find the x-intercepts, you swap the sign, right? Same thing here with the vertex, swap that sign. If the vertex is at 3, 5, where is the axis of symmetry? What always matches axis of symmetry and vertex? The x value. We already have the x value of the vertex, so that means the axis of symmetry is got to be 3. It has to match that. We don't have to do any work for it. We got 2 things for free that time. I like free things most of the time. Now, let's go ahead and get the y-intercept. We'll get the x-intercept in a minute. Y-intercept's easier. How do you find a y-intercept for any kind of equation? Plug what in? A 0 for x. No matter what kind of equation, when we get to hard ones next week, still to find the y-intercept, plug a 0 in. So that's what we're going to do here. F of 0, 2 parentheses 0 minus 3 squared plus 5. If I go to my calculator and use it to help me if I want to, 2 parentheses x minus 3 close parentheses squared plus 5. Hit graph, and if I'm going to hit trace 0, 23. If you work that out, negative 3 squared is 9 times 2 is 18. 18 plus 5 is 23. Do it manually. So the y-intercept is at 0, 23. Pretty good ways up. I hit trace 0 once I typed in the equation and graphed it. Get it. If I just need a single order pair, that's usually how I do it. You could use the table to do it if you wanted to, but I use the trace function. Now, x-intercept's the harder part. It's not in standard form, so that doesn't allow us to use the quadratic formula. We would have to multiply it out to get it into standard form. That seems like a lot of extra work. It was a lot of extra work on the if we did it that way for the intercept form. So there's got to be a better way. There is. There's a wonderful method called solving by square roots that we can use. So we got 2 parentheses x minus 3 squared plus 5. And to find an x-intercept, we take the problem and set it equal to 0 every time. No matter what kind of problem we're dealing with. Later on, we get into bigger problems. Once x-intercept, set the thing equal to 0. And that's how you get an x-intercept. Okay, so we're going to solve this by square roots. So to solve something by square roots, you've got to get the squared part by itself. For this particular problem, the squared part is this parentheses here. So I want to isolate that parentheses. So what's my first move? Yeah, move the 5 by subtraction. So that's going to give me 2 parentheses x minus 3 squared equals negative 5. Yeah, and then divide by that 2. And I get x minus 3 squared is equal to negative 5 over 2. What happens, or how can I get rid of this squared? Yeah, if it were just x squared equals negative 5 over 2, you'd take the square roots each side, right? Same thing here, it's just got that parentheses in there. So if I take the square root of both sides, plus or minus on the number side, remember, that's going to give us x minus 3 equals plus or minus the square root of 5, negative 5 over 2. I didn't write my square root big enough. There we go. And then to get x by itself, I add 3 to both sides. So that's going to be x equals 3 plus or minus the square root of negative 5 over 2. What's the problem here? What does that do? Makes it a complex solution, right? I radical 5 over 2. That's complex. If we look at the graph, is that thing going to hit the x-axis? No. No, it's opening up. So that means it's going to keep going up, right? And it's never going to hit the x-axis. The reason it's not going to hit the x-axis is because the answers to the problem when you set it equal to 0 were complex. So that means we don't have any x-intercepts for this one. There are none. We could see that from the graph, but we could also see that from our solutions to the equation. And we could solve that, but because this is complex, there are no x-intercepts. Anytime you're trying to find an x-intercept for whatever kind of problem we're doing quadratics today. Next week, we're doing 5th degree polynomials. If it's complex, then it's not going to hit the x-axis. Complex answers don't hit the x-axis. Real answers do, like negative 3 and 5. Those are real numbers. But if it's got the I in there, it ain't going to hit the x-axis. Okay? Now, We found the x-intercept, or the lack thereof. We found the y-intercept. Now let's make our table. What goes in the center of our table? Vertex, which is 3, 5. So I'm going to go 2, 1, 4, 5. And I'm just going to plug in those with my table on the calculator. Second graph. I forgot the numbers on it. 1, 2, 3, 4, 5. I should have forgot that. 1, 2, 3, 4, 5. 13, 7, 5, 7, 13. And I'm going to draw the graph of that. I'm going to, might want to flip over to the back side of your graph paper, because this one's kind of big. Try to fit it on there. You could change the scale of your X or Y, your Y axis, go by 2s or something like that if you wanted to make it smaller. So I'm going to plot those points. 1, 13. 2, 7. 3, 5. And then it was the y-intercept was 0, 23, wasn't it? It's 13, 14, 15, 16, 17, 18, 19, 20. I don't have room. It's okay. No, it's going to be up there somewhere. And there I have a little bit better picture of what my calculator's showing because I can see more of it. But it's in general the same shape as the one on my calculator, and in the same quadrant. It's in quadrant 1 of the coordinate plane. So this stuff is not hard. It's just a lot of pieces that, you know, if you mess up one of them, it could mess up the next one. So you got to use the checkpoints. When you go to do the vertex, check it with the calculator. Make sure it's the right one before you move on to the next thing. Okay. If it's not, then you got to go back and recalculate out of that. So, but overall, pretty easy thing. And it should have been stuff that you've all